Hey guys, in today's video we are going to look at a Leetcode problem, and the problem's name is maximum area of longest diagonal angle. So in this question we are given a 2D array called dimensions, and for every element inside the array, the first index of that element is going to represent the length, and the second index, the dimensions of I of 1 is going to represent the width, I of 0 is length. So for example, if we take this, so this is one element, right? So I is equal to 0 in this case, so dimension 0 of 0 is going to represent the length, which is equal to 9, and dimensions of 0 of 1 is going to represent the width, which is equal to 3. So this is going to represent I, and this is going to represent 0 or 1. 0 is length and 1 is width. Now this is our task. Our task is to return the area of the rectangle having the longest diagonal. And if there are multiple rectangles with longest diagonal, we have to return the area of the rectangle having the maximum area. So let's take this test case, which I've written here. So this is the example 1. Now we have two rectangles. So this is index position 0 and this is index position 1. So let's find the diagonal of those two rectangles. So let's represent the first rectangle. So length is 9 and width is 3. So this is the length and this is the width. So to find the diagonal, this is the diagonal, right? So the formula for diagonal is going to be is equal to square root of L square plus width square. So this is the Pythagoras theorem, right? Since this is the right angle and this is the hypotenuse, so the hypotenuse of this right angle triangle is going to be the diagonal of the rectangle. So let's find the diagonal length. So this is going to be 9 square plus 3 square, so is equal to root of 81 plus 9, and root of 90 is equal to 9.487. So this is the 0th element here. Now let's do for the first element. So length is equal to 8 and 6 is equal to width. So the diagonal length is equal to square root of L square plus width square. So root of 8 square plus 6 square. So root of 64 plus 36 is equal to root of 100. So root of 100 is equal to 10. So the diagonal length is 10. So among these two elements, the second rectangle is having greater diagonal length, since 10 is greater than 9.487. So this is having the greater diagonal, and the task is to return the area of the rectangle. Area of rectangle is equal to length into breadth. So here width. So area is 8 into 6 is equal to 48. So 48 is the output for this question, which is matching here. And this can be a tricky part. If there are multiple rectangles with the longest diagonal, return the area of the rectangle having the maximum area. For example, this is 10 and this is also 10. We have to find the area, and the area is equal to 9 into 3 is equal to 27. In this case, again 48 will be the output, even though both of them are having the same diagonal length. So let's implement the same steps in a Java program and carefully look at this condition and how are you capturing this condition in code. So I'm creating two variables, max diagonal and max area. Max diagonal is of double data type because we are finding out the square root. Now I'm iterating through a for each loop for all the dimensions present inside the. So if we take this example 9, 3, 8, 6. So this is a 2D array. So in every iteration I'm taking one dimension. So we start with the first thing. So dimension is now having 9, 3. So length is at index position 0 and width is at index position 1. So 9 is here and 3 is here. Now we are finding the diagonal length. So square root of 9 square plus 3 square, which is equal to 9.487. So diagonal is having 9.487. And immediately we are going to find the area of that rectangle. So 9 into 3 is equal to 27. Now for every diagonal, I'm going to check with the max diagonal. Max diagonal is initially 0. Whenever you encounter this condition as true, it means the current diagonal strength is greater than the all diagonals calculated till now. So assign that value diagonal to max diagonal and assign this area to max area. So this is going to keep track of the max diagonal and max area. And this condition we are checking here if there are multiple rectangles having the same diagonal. So if the current diagonal is equal to the max diagonal, it means there was already a rectangle having the same diagonal value as current rectangle's diagonal value. Then in that case, I'm going to update the max area again because they're asking us to return the maximum area of the rectangle. So I'm comparing the current area with the max area again. So this check is important. So this will happen for all the elements inside the input given to us. And finally, we're going to return the max area because they're asking us to return the area. So the time complexity of this approach is O of n, where n is the length of the input given to us. And the space complexity is constant O of 1 because we're not using any extra space to solve this question. That's it guys. Thank you for watching and I'll see you in the next video.